That's close enough. All right, so picking up where we left off last time, we were talking about loops, and that Python doesn't really have for loops. They have for each loops. And so you have to give it a collection. And if you want a traditional for loop, like when you're running index variables 1, 2, 3, 4, 5, right, then you need to use this range function. And if you used it in just straightforward here, you can provide one argument, you can provide 2 arguments, or you can provide 3 arguments. All 3 arguments are listed here: the start, stop, and step. Right? That start is going to be where the loop starts. Right? The stop here is where it stops. Right? -1. Right? Because it will not include that last value. And then step is how much it increments. And right before class started here, I was looking for the documentation on it. And when you search for documentation for Python, you are going to get 50 different websites, everything from W3 Schools down to Real Python or Tutorials Cart, a bunch of garbage, right? Make sure that you're always going to docs.python.org because that's the official documentation, right? I guess this is a testament to just how widespread Python is among beginners, that the official documentation does not even appear in the first page of DuckDuckGo results. So make sure that you're going to the right one, and then you can always find, well, how does range work again? Start, stop, step, etc. Right? Or you can call it with just a stop. I forget what the convention here is on these forward slashes, but we'll write our own functions and later on, and we'll find that you can only ever write one function with that name. So there aren't actually 2 functions called range. There's one function called range that is taking optionally up to 3 arguments, and then it has logic to figure out how many arguments did they provide, and then it acts accordingly. Right? But always be going to docs.python.org. Right? All right, so any questions on... I think we've gone through the basics, we've gone through conditionals, and now we've gone through loops, right? Well, loops are only useful if you have something to loop over, right? And so that's where collections come in. Python has several collections. We're going to focus on 3 of them. One of them is lists, sets, and the other is dictionaries. Lists are ordered collections of things with duplicates, possible duplicates, and 0 indexed. In other words, they're just like lists in Java. Or they're kind of like arrays in C, except that they can grow or they can shrink however you want to use them. Sets are kind of like lists, but they're unordered and they are unique elements, so they do not allow duplicates. And then dictionaries are what Python calls maps. Maps are key value pair mappings, right? Where you can map one thing to another thing. Let's get started with lists up here. Right? So let me go ahead and get rid of all this. Right? Let's just go ahead and create an empty that's not comments. Create an empty list. One way that you can do it is say primes is equal to an empty list. Lists use the square bracket syntax here. Another way that you could have done this is primes is equal to list. Right? That also creates an empty list. Generally, I like to do it. I don't know if there's a Pythonic way, like one of those is more Pythonic than the other. This is generally what I do, though, right? If you want to add something to it, then you can. Primes sub 0 is equal to 42, right? Let's try it like that. And we can run it, but it's not going to do anything yet, right? Oops, that's not right. That should create it. Oh no, sorry, it's what? How do you add something? Dot append, right? It's not add because that would be, it doesn't have support for add. Append is going to be putting it where do you think in the list? At the end, right? So adds to the end of the list, right? There we go. And then we can print it out if you want to. Print primes. It's not going to look very nice though, in my opinion, right? 42, right? Instead, we can make it look prettier. And we can make it look prettier using pretty printing, right? We need to bring that in, though. That's going to be a import. That's a pretty printing library. Instead of print, I always like to use pprint, print.pprint, right? Too many P's there. There we go. All right, and that's going to, it has the same behavior here, but if you have more complex objects, very, very long lists, it'll do line breaks for you. We'll see the clear difference when we actually do dictionaries here. It'll print it out in a nice format, and so I always use p printing or pretty printing, right? Another way that you could have done this is by assigning it when you create it. Primes is equal to, I don't know, 2, 3, 5, 7, 11, 13, right? And let's print it out again. Note there that that's a completely different list because it's a different way of initializing it, right? It automatically creates things. There's no memory management. There's no making sure that there's enough memory there, right? It just takes care of it for you, right? What happened to that old list? It got garbage collected automatically just like Java, right? Okay. All right, so there is, how do I know how big it is, right? So the size of an array is determined using, not an array, I shouldn't call it an array, it's a list. A list can be found using len. Remember the len is the length of things, so n is equal to length of primes, right? And here I'll just print n. Right? How many things are in there? Looks like 6. Oh, there are 6 things in there. That means that you could go ahead and do the following if you wanted to. For I in range of the length of primes, use indexing here to, there we go, and print, let's go ahead and go with a formatted string here. Primes sub whatever that is equal to whatever that is. So I and primes sub I. In other words, you can use the regular old array kind of syntax to access individual elements here. This should work. Right, there we go. Primes of 0, 2, 3, 4, 5. Yeah, there are 6 things there. Right? All right, but that's not really the Pythonic way of doing it. The Pythonic way of doing it would be to iterate over the collection itself for x in primes. Right? Now I don't have to create an index variable to and rely on range to increment that for me. I can just go ahead and print it out directly. Formatted, right? And x, there. The disadvantage here is I don't have access to the index value, but rarely do you actually need that. Usually you only need the index value to get the value out of the collection that you're iterating over. So ignore it, right? For x and primes, okay? Let's see. So you can add stuff, you can append stuff. I don't know, you can append entire things, I think. Primes.append. Can you do this? Let's find out. 10, 20, and 30. I don't think that this is allowed, is it? There's another way of doing it. No, it is allowed. Let's find out. pprint.pprint primes. 10, 20, and 30 is no longer prime, though. All right. What did it actually append, though? The list itself. What does that tell you about lists? They're mixed types. Right? It can hold integers, it can hold doubles, it can hold lists of lists if you really want to, right? There is no fixed value or fixed type for a list, okay? So if you wanted to append, I think that there's append all, add all, or what is it? How should we look that up? Python, add a collection to a list. All right. Add each or something like that. Add items. All right, we'll go ahead and go with this one. No, that's not what I want. I don't want to insert either. Extend, there it is. Extend, right? So instead, if you wanted, say, let's go with this, extend. Let me go ahead and get rid of this so that we can start fresh. There we go. And there. Now it appended each one. In other words, it appended 10 and then 20 and then 30. It results in only one list, not a list of integers and another list over there, right? Okay. You can append other things, for primes dot append hello, right? Again, mixed types here, right? That you're gonna get a collection that can hold whatever you want whenever you want, right? Unfortunately, that seems okay at first, but then you start realizing, well, wait a second, there's no way to check consistency. If I'm expecting a list that's being passed to a function to have only integers, right? Now anybody can pass whatever the hell they want to my function. And it's on me to either go through and check, is everything an integer like I expect? and then throw an exception if it's not, or just let the chips fall where they may, right? And iterate over it and try to add hello to a running total, right? And then it'll result in a runtime error, and it'll kill the program, right? So there's nothing that the compiler can check anymore because there is no compiler, right? All right, let's start fresh here, array, or I don't even want to call it array. Should I call it a list, by the way? No, don't do that. Because actually, I don't think you can. Actually, let's try it. What happens here? List is equal to that. List.append. List.append 10. Right? And then let's go ahead and print out that list. What do you think is going to happen here? Oh, it actually worked. I'm really surprised on that. If you basically you can reassign the values, right? I think that if you let's try this now. X is equal to list. Can you still do that? There we go. What have I done? I've broken Python. List is a function somewhere that returns a list when you call it, right? Like we did way up at the top there. When I did say instead of primes is equal to that, primes is equal to list, right? But by resetting it, I've basically deleted that function, at least for the duration of my script here. Don't use the keywords that are built in. Don't use the standard functions that are built in. That's definitely not something that you should be doing, right? All right, let's go with something more meaningful. I don't know, numbers? There we go. Or let's go with names. Names is equal to list. There we go. Names.append. All right, Chris. Names.append. Let's go with John, Jane, and Alex. Bregman just signed. All right, pprint names. Right. I would go with Bull's names, but I don't know how to spell any of them. How do you spell Vucevic? Right. Right, there we go. Chris, John, Jane, Alex. Let's go ahead and add something, but add it to a different location. Names.add. At the front, Vucevic. All right, I have no idea. All right, and let's go ahead and print that out again. In other words, you don't always have to append. You can add things to the beginning. It's not add. Where is it? It was insert. There we go. Sorry, insert. There is no add. You just have to. I just have to get used to that. Like I've not gotten used to it yet. Is that how you spell Vucevic? Nobody knows. All right. Nobody follow basketball. No. Okay. But not the Bulls. Okay. There's very little reason to right now. You could go with Bears instead. There's a reason to do that one, but no. Broncos are done, man. All right. So, what else can you do here? You can remove things. For example, what is it? I think it names.remove. Let's go ahead and remove the Vucevic that we just added there. All right, there we go. It's not remove. Dang it! I forget. Python remove. I have it over here somewhere. It deletes the occurrence of a specified value. Okay. There's no index-based remove. Say what? Well, pop is going to do. Pop is very special. It's going to be the last one always. Oh, pop, and then you can provide it. Okay. So let's go with pop. Pop with no. There we go. So what did it pop? It popped Alex. In other words, the last one. That's the default. If you want to remove the first one, you pop 0 instead. If you want to remove the second one, you pop 1 instead. So the default is to remove the last one, and then if you provide an index, that'll remove an arbitrary one. You can also do it by, as it said, you can do remove, but you'd have to actually provide the entire string there, like remove Vucevic instead, right? So remove via index, right? Just pop. All right, here's some other cool stuff. You can get a sub list using the following syntax. So for example, I just, I've got 4 of them here. Let's go ahead and go with the first 2. So names is equal to names or actually let's call it subnames. Subnames is equal to names of, say, 0 through 1. Let's say 2. There we go. This gets the first 2. This gets the elements 0 through 2 minus 1, which is going to be equal to 1. So in other words, 0 and 1. And pprint sub names. There we go. Okay. All right. And it's just Vucevic and John there. Right. You can go ahead and use one or the other instead. So for example, if I just said, say 2 through whatever, it'll start at the index 2 and then go all the way to the end. In this case, it'll get Jane and Alex, right? Because that's all that remains there. If you want to, you can go ahead and use the syntax on the other end as well. Everything from the beginning to there, right? And what will that'll get everything except for the last one, right? Vucevic, John, and Jane. Right? Alex is excluded because we didn't go up to, but not including 4. Remember, it's always going to be inclusive, exclusive. So in general, this is inclusive and then exclusive. Right? So it's going to include that first one, but it's not. It's going to go -1 on the second one. Why? Because that's how 0 indexing works. Right? You're going to find that pattern all over the place. Right? Is there another cool thing I wanted to show you? Oh yeah, here's one last cool thing for lists, and then we'll look at sets. You can use negative indexing. Right? So for example, x is equal to names sub -1. Oops, there we go. Print x. Before we do that, let's go ahead and print out the names again, just so that we have a reference for what the names are. Right? And let's understand what happens here. There are the names. What happens with -1? There are 4 of them, so it's 0, 1, 2, 3. But if I go with negative, what happens? It wraps around back to the beginning, right? So you can use negative indexing, and I think that you can use -2. Who would that get me? Jane, right? There we go. And then it wraps around all the way. Does it work in the other direction? Let's find out. What if I wanted, now there are 4 of them in there, so if I had 0, 1, 2, 3, 4, might it go back around to the beginning? Let's find out. No. It only works in the negative direction. Right? And it only works in like the negative. I think if you can fall off the negative as well, right? So you cannot use indexing that is larger. Right? And so I will get rid of all of this. Right? Oops. Let's get rid of that and there. Ooh, same trick as in C or Java or whatever. You can comment out an entire block by going command /. Even though it's a /, right? It'll interpret, oh, this is Python, so what is the comment? It's going to be a hash. You don't have to go up to the 3 and get the hash there. Right? Maybe it works. I don't know. I've never tried it. No. That just went, that went on to the next tab in my browser. Right? So yeah, you can't do that. All right. What about sets? All right. So names dot here is where you can use add, by the way. This is why I always get confused. Let's go ahead and go. Let's add me. Let's add Dansby. Let's add Nico. Let's add Alex now. There you go. And we can pretty print this stuff, names. How is it going to be different for pretty printing here? Right? Instead of the square brackets, what did it format it as? As curly brackets. Now, curly brackets tells me in coding that's an array, but it's not an array. That's more the mathematical interpretation. In 235, you'll eventually get to sets. Maybe you've started already. And what is set notation? It's going to be the curly brackets there. Right? What happens if I try to add Alex again? I want 2 Bregmans. Are we going to be allowed duplicates? Nope. No effect. And also, is that the order that I added them? The order that I added them was me, Dansby, Nico, and Alex. But is that the order that it's printing them out in? Nope. Why? Because sets are unordered collections of unique elements. Okay. All right, so there's sets, and then you can do other. You can't do anything index-based with them. For example, the negative indexing, these sub-list tricks, right? None of that can be done with sets because they are not ordered. So there's no index-based stuff with it at all. In order to do stuff with it, though, you can use the same syntax. So, for example, for name in names, right? Print name, right? There. You can iterate over the set. There's no guarantee that one iteration will not be the same as the next, especially if you change it, if you add something to it later on. You might get a completely different order, right? You can convert sets to lists and lists to sets. So, for example, my name is names is now a set. Let's go ahead and convert it to a list so that we can actually sort it, because you can't sort sets, right? Because they're unordered. But I can call it names list, right, is equal to list of names. There we go. All I have to do is provide this. This is a constructor, basically. This is a copy constructor. And I can see now that there is order to this names list. Right? It's not. It's the order that was the iterator order, but in this case, if I can now treat it like a regular old array. If I wanted to remove something, dot what would it be? Insert at 0. Let's see. Mat. There we go. And then pretty print it again. Now Matt is at the end because now, oops, sorry, I put it at the beginning, insert. And now there's an ordering again. Okay. How do you go lists to sets? Well, I've got that name list. I can just say names set is equal to set of names list. Right? And once again, now it's converted back to a set, an unordered collection of things. Right? There we go. What would have happened if in the interim I had added something? Names list dot add, or append, sorry. Let's add another Alex in there. Now that's going to work for the list because lists allow duplicates, right? There's an Alex and there's an Alex. But if I did it on, oops, name set, it should be set. Why doesn't it get, ooh. Names list, there we go, thank you. I'm not hallucinating, just bad copy pasta there. What happened to my duplicate Alex? Got punted out, right? Okay. Dictionaries. Dictionaries, there we go. Dictionaries are simply key value pairs. I'm going to start out with a name map, say, right? Now here I'm going to use curly brackets. You can actually use curly brackets for sets too, I believe, but I just use sets, the function called a set. And what you can do is you can name your own key value pairs. So foo, right? Or I guess let's go with Alex. He took number 3, Alex. And then comma. Nico is number 2, so Nico, right? Dansby is, I don't remember his number. Who else could I have? 54 at some point was PCA, right? There we go. But you can also do other things. For example, 3.5, I'll map that to foo, right? Make sure that commas are in there, right? Can you also use strings? Yes, you can. Let's see, Jane will map to Austin. There we go. And make sure that you've got your commas there, right? In other words, your keys can be integers, floating point numbers, I believe. We'll find out here in a second, and strings. And it can map to whatever you want. For example, I could map, say, pi to 3.14. Right? There we go. And this should be fine. Right? Yeah, and let's go ahead and pretty print this. This is why I use pretty printing, because if I said print names map or name map, it's not going to look very nice. Right? I mean, it's going to elongate it all like this. But if I use pretty print, pprint.pprint, right, it's going to look way nicer. Oh, no, come on. Pprint.p, it's just because it's so short. If I had added more things to it, I don't know. Okay. Oh, by the way, can I do duplicates? Let's find that out. Let's go with E. It's going to be 2.71. Foo maps to bar Let's try foo with a capital F to see if it's case sensitive. Baz, there we go. There, all right. So make some observations immediately about this, all right? Those four are pretty straightforward. Yes, you can use integers or doubles as keys. What about that duplicate pi there, though? Does that show up twice? Nope. Keys have to be unique. However, values do not have to be unique. I can go ahead and put in 4.5 and map it to the same foo. And here you'll see foo comes up twice as 3.5 and 4.5. But otherwise, is it case sensitive? Oh, careful. Is it? Foo and foo. Yep, it is. It's just that I put those right next to each other, but did they appear right next to each other over here? So it's unordered, right? How do you iterate over something like this, right? There are several different ways. The first way that I'm going to show, but before we do that though, you can add, remove after the fact, right? So for example, if I wanted to add something, I could say names map, is it name map or name map, sorry. Name map of say, I don't know, Ian. It will be equal to Hap. There we go. No semicolon. That's how you can add things. There's the key, right? And there's the value. Right? You can retrieve things. Retrieve. Right? X is equal to name map of, what did I do for foo? Right? We'll find out here in a second. Print X. Right? There we go. And then there's bar. Apparently I mapped foo to bar. Right? So you can retrieve things. Remember CRUD, create, retrieve, update, and destroy. I've shown you a way that you can create a map, that you can put stuff in, that you can retrieve stuff. How do you take stuff out? Let's see, isn't it remove? I forget now. You can always reset, so reset or update, right? You can say name map of foo. Before that was bar, right? Now I'll make it equal to hello. And then we can print this out. Printing it out is just easiest to see how it changes stuff. There, now foo is mapping to hello. Is it unset? No, I'm thinking of Python there, or PHP there. How do you remove something? Anybody know off the top of their head? Python remove from map. Isn't it? Okay, I guess it's pop there too. Fine. Let's try it out. Name map dot pop. Let's pop foo. Right. That'll do it by the key, right? Not by the value necessarily. Otherwise, it would be popping out a whole bunch of things. There we go. It got rid of that foo mapping to hello. So we can put stuff in. We can retrieve stuff. We can take stuff out. We can update stuff. How do we iterate? So iterations, right? Yeah, and then we'll talk about comprehensions later. So, okay, let's do it this way. For key value in name map, I think it's items. Right, there we go. Then I can say print, and let's do a formatted printing here. The key will map to the value. There we go. I think that this is it. No. What is it? Is it a comma? Yeah, it's going to be a comma. Thank you. There we go. All right, 3 maps to Alex, 2 maps to Nico, right? Dot, 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 all the way to Ian. Did I get the same order, by the way, as the print order up here? I don't think I did. Did I? No. So again, it's unordered, right? But this is the best way that you can do it. Just go ahead and you can name this whatever you want. You can name this key 1K and then value, right? Key and value. You just have to make sure that you're consistent about it. And consistent and spell it correctly, right? But you have to call this dot items here, right? That's how I would recommend that you do it. You can do it in other ways. For example, for X in name map, right? Will this do values or will this do keys? Let's find out. Print X. Right? Were those keys or were those values? Keys. So this is iteration over keys. And then if you want, you can use that key to get the value. What if you needed to iterate over the values, though? Iteration over values. For x in name map dot items was a key value pair, so it's a pairing. If it's just the values, I believe it's values, isn't it? Print x. There we go. And those are definitely the values. So use one of these. Iteration over key value pairs. You use items. If you want to do it over the keys, you just do a straight up for loop. If you wanted to do it over values, then the dot values gives you all the values. Okay? All right. Any questions on that so far? Again, maps are way better. Right? If I need to, I would dump a list to a map to a list. But ultimately, what I would do is I would use dictionaries for most everything. Unfortunately, dictionaries are not the same thing as maps in Java. In Java, your keys can be whatever you want. It could be a person object, and then you map it to an integer. In Python, without bringing in more libraries, I believe, you're stuck with integers, the built-in types, integers, floating point numbers, and strings as your keys. Your values can be whatever you want, right? And we'll talk about how to create your own types later on. Actually, I don't want to get rid of all of that because I do want my pretty printing library there for demonstration. All right. Let's talk about comprehensions. All right. So this is something that might be new to a lot of you because it's more functional programming style, right? But what I want to do is let me go ahead and grab on my primes again. Right. And what I want to do is I want to modify that list. Say that I wanted to, well, first of all, you can sum things up, right? Sum up the primes, right? Here, should I do this? Sum is equal to sum of primes. Is that a good idea to use a variable that has the same name as a function? Probably not. Let's use an alias, total, and then print total, right? What is, so it's 100, is that correct? I have no idea. But there, the sum of the first 4, 5, 6, 7, 8, 9. Sum of the first 9 primes apparently is 100. Okay. There are other built-in functions like this. Just go ahead and search around for what's built in. Is there an average function? I don't think it's built in. If it is, it would be called mean. Usually, you bring in a library to do something like that anyway. But what I want to do is I want to create a new list of primes that are doubled, right? Or say, create a new list of only even numbers from a random list, right? So for example, let me go ahead and create this numbers is equal to 5, 7, 3, or blah, 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 blah. There we go. And 10, right? So let's go with this first one here. Create a new list of primes that are all doubled. In other words, I want to go through and say 2 times 2. 3 times 2, 5 times 2, 7 times 2. I could, of course, write another loop to do this. I could say result is equal to a list like this, and then I could say for x in primes, I could say result dot append x times 2, right? And that would work. Pprint dot pprint result, right? There. Are they all doubled? Yeah. That's not really the Pythonic way of doing things, though. The Pythonic way of doing things would be what's called a comprehension. Right? Now, what this is going to be new syntax for everyone. X for x in primes, and I will double it. X times 2. Actually, let's go. Yeah, we'll go like that, right? And then I can get rid of this entire for loop here. In other words, the for loop is built inside of this list declaration. Now, again, it's going to be, this is the result here that gets added to the list. And then this for is running over for each x in primes. Right? Let's go ahead and see the result of that. It's exactly as before, but it's much more compact. Right? You can also do this for like simple initializations. Simple initializations. Right? For example, if I want an array of 1s, and I want 10 of them, I could say for I in range of 10, right? And let's print that out. Now I'm going to have an array of 10 1s, right? In other words, this does not have to be a variable that is involved in anything. It could just be whatever. Whatever is in there, whatever is placed there is the thing that gets placed in your list. This is how many times it iterates over it, right? So it's a little bit more compact way of doing things. And at first it might be, well, that's simple. Who cares, right? But you can do some really, really powerful things that we'll eventually get to. For example, I want to filter these things. I want evens is equal to, let's go ahead and go with x for x in numbers. That won't do anything other than copy the entire list. Right? I want to ensure that it only copies in x if x is even. So you can add a condition at the end. If x, how do I tell if x is even, by the way? Mod 2 is equal to, 0. There we go. And then we can print that out. It will only retain in that copy things that are even, that meet that condition right there. And was that correct? Looks like it to me. 5, 7, 3, they're all thrown out. 4, 8 is included. 9 is thrown out. 2 is included, et cetera, et cetera. Right? And then you can, do any combination thereof. Right? I will go ahead and retain the evens, but then I will add 1 to each one of them to get 5, 9, 3, 5. Right? So lots of different things that you can do here. Right? Let's see, what else? I think you can do set comprehensions. Let's see, sets, question mark. Odds is equal to x for x in numbers if x mod 2 is equal to 1, and then print that. And the only different, not evens, but odds. I think you can do this. Yes, you can. Right? What was the difference between these two? The square brackets versus the curly brackets. Curly brackets made it into a set. Did it retain any duplicates, by the way? Did I have duplicates? Yes, I did. I had 3 there twice, at least, but there are no duplicates down here. Right? So if you want to eliminate duplicates, you would use a set. What about maps? And let me go ahead and get rid of that question mark, because yes, we can definitely do it. Right? What's a good example here? I don't know. I know. Let's just reuse odds. Foo is equal to. You use the same square, the curly brackets here, but you use k comma v for k in numbers, and then instead of v, I don't have a v here, so what I'll do is k plus 1. And let's go ahead and print out numbers to see what we've got, and then let's print out foo to see what we've created. Right? What is it? Dang it! Is it a colon now? Okay, I always get those backwards. Thank you. There we go. All right, so we've got 5, 7, 3, ... So 5 would end up being mapped to 6 because I said k plus 1. 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, etc. Right? Okay. So ways that you can do that. Okay. We will do more complex stuff later on, though. Here's a, well, actually, yeah, this is a good use case. Read in command line arguments and convert them to an integer array. Right? So for example, if I were to execute this with 10, 20, and 30, I want 10, 20, and 30 in an array, and I want them all converted automatically to integers. Here's a list comprehension for doing that. So now I'll say numbers is equal to x for x in sys.argv. Argv, I think it is, but I do need to bring that in now. Import. Right? Sys. Right? And then pretty print this. Well, we're not done yet. We haven't converted anything yet. Right? So let's go ahead and run this. It's demo.py because the first one is always the executable file name, or in this case, the script name, 10, 20, and 30, but they're treated as strings. So let's go ahead and convert it over to an integer, int x. Is this going to work? How is it going to treat that demo.py as an integer? Oh, it's going to fail on that. Right? Well, that's okay. I just want to ignore the first one. How can I ignore the first one? By starting at the second one and going to the end. Right? So you can combine these things for very, very powerful statements in very, very compact code. Right? That's why Python is a quick programming language to get something done. Right? If it's quick, and I'd say it's quick and dirty. Some people would say it's quick and beautiful, but it gets dirty if you're doing complex stuff, right? And there's 10, 20, and 30. All of them are treated like integers. What if I wanted to treat them like floats instead? Float. There we go. Yay. Right. And I'll keep it as an integer here. Right. Oh, one last thing before we leave today. Tuples. All right. So what is a tuple? You can have doubles. You can have not doubles as in like a floating point number double. Triples, quadruples. What comes after quadruples? Quintuples, right? Et cetera, et cetera, et cetera. Right. The way that you can do this is by here's my pair. Right. 10 and 20, 10.5. There we go. pprint pair. It's going to end up treating it like a list, right? But it's going to have parentheses here. If you wanted to get the first one out of that pair, you could. First is equal to pair sub 0, right? Second would equal to pair sub 1. In other words, you can use 0 indexing to retrieve any one of these things. You can't reset it though, but it's a really nice way of collecting things together in a fixed tuple, right? For example, people, person. Let's go with person. My, say, first name, Chris, my last name, yay, and my NUID, 351400602. Yeah, that's good, right? So, pprint person, right? There is our rudimentary object, right? I've collected 3 pieces of data together into one logical object. There are better ways of doing it, classes that we'll talk about later on. But this is a quick and dirty way of collecting things together, right? If you had, say, like first names is equal to, say, Chris, Jane, and John, and last names is equal to a list here, Burke, Smith, Smithy. All right, there we go. Let's go ahead and bring those together using a list comprehension now. Right? People is equal to a list comprehension that groups in the first and the last for first in first names. There we go. For last in last names. Right? There, I've got 2 loops in a list comprehension. Predict what this is going to do, though, before I run it. Every pair, right? It'll be Chris Burke, Chris Smith, Chris Smithy, right? It'll be Jane Burke, Jane Smith, Jane Smithy. It'll be John Burke, et cetera, right? So in other words, this is how you can do what's called a Cartesian product if you're covering that eventually in 235, right? That's not what I wanted, though, right? I wanted to match the first with the second, the first, and the okay. Well, that just means that I have to do first names sub I, and last names sub I for I in what? I in range of, well, length of first names. There we go. And that will, I believe, get me what I want. Yep, there. Everybody's matched together. However, careful, what's going to happen here? Dansby again. Right? Is Dansby going to have a corresponding last name in that second one? So guess what happens? Right? Index out of bounds exceptions. Right? So you have to you do have to write some other code to make sure that everything is safe. Right? But otherwise, list comprehensions, really, really nice and convenient. Right? Then you can do that. Last name last names sub I. I will map that to, that's going to be really cool. What will it be? Now it's a map that maps a person's last name to their full name, right? So you can do a lot of powerful stuff with these comprehensions. List comprehensions, set comprehensions, and yeah, what do I want to say? Dictionary comprehensions, right? Or dict for short, D-I-C-T, right? That's what the Pythoners say all the time. Right? Use a dictionary. Right? No questions? No? I can show you one last trick, I guess. Yeah. Well, it's basically what we just covered here. Basically, what would happen if you wanted a traditional for loop like this, a nested for loop like this, right? What you could do is you could create pairs instead, right? For example, I'll just bring this over here, right? Here's my list comprehension to do that. I comma j for I in range up to n minus 1. Why? Because I'm going up to n minus 2 here. And then for j in range of starting at I plus 1 up to n minus 1. Right? And that will get me, what I don't have an n here. Let's keep it simple. Let's go 4 and pprint, all unique pairs. Right? And I don't have to write two traditional for loops for this. Right? I can go ahead and create all of those, then iterate over those pairs for x comma y in all unique pairs, right? Print x, x, and print y. There we go. Right. There, it's printing, it's printing 0, 1, 0, 2, 0, 3, right? Because I'm printing them on two different lines. But you can use tuple syntax in your for loop as well, right? If you wanted to do this differently, you could say z, and then you'd have to spread it out. X is equal to z sub 0, and then x y is equal to z sub 1. But even that can be improved upon. Here's something really cool. X comma y is equal to z. Right? It unpacks it. Right? In other words, it takes this tuple, sees, oh, you want to unpack that pair into x and y. I'll go ahead and do that for you. Right? So lots of really cool syntax that you can use with Python. But, trust me that it gets unwieldy very, very quickly. So Python is not the perfect programming language by far. It falls very, very short of that. Performance for one thing. Right? All right. Any questions? All right. I'll show you some more cool stuff on Wednesday because Monday, no class because of Martin Luther King Day.